consider about the theorem now. We are going to prove the theorem to indicate this contact of tangent and the radius are perpendicular with each other. That's the theorem we are going to derive here. Okay, for first we have to indicate when we are deriving something, we have to do three things. First one is D, then C, and T and P. Okay, DCTP. D means data. We have to write the data which we were looking for. Okay, here you can see there are two tangents. Okay, there are two tangents. That means let's have a name for them. D and E. D and E. Okay, first of all, the data DP and EP are tangents. Are tangents for this circle. Okay, tangents. That's enough. DP and EP are tangents. That's the first thing you should write. Are tangent. Then second thing is construction. For this one, no need to draw any construction. Let's obligate that one. Third one is to be proved. Okay, to be proved means what is the thing we are going to prove? To be proved. We are going to prove AP equals to BP. First thing, by showing these two triangles are congruent with each other. Okay, for that we are going to prove AP and equals to BP. AP and BP equal. These two are equal. That's the first thing we are going to derive. Then APO. APO. This angle is equals to this angle. That's the thing we are going to prove after that. APO angle equals to, write the theorem with me. Okay, write the proof with me. APO and BPO. These are equal. Then third thing, POA. POA. That means this angle. We already know. We studied the theorem. The radius and this are in perpendicular relationship. Okay, that one we already know. That is the obvious one. We already know that. By using that, we are going to show these two triangles are congruent with each other. Okay, congruent. In congruent triangles, all the remaining, okay, in congruent triangles, corresponding remaining elements are also equal. Remaining elements are also equal. That's the thing we are going to find. Yeah, then AOP equals to BOP. Okay. Then let's prove. Mostly the proving questions related to triangles are mostly congruence. Okay. Prove. DCTP. The data construction to be proved and proof. DCTP. That we omitted C. That means there is no any construction needed for this one. Okay. So we are going to derive the proof. For that, in the triangle, think about the triangle POA and triangle BOP. In the triangle, we already know that these are perpendicular. Okay, we studied that this theorem already. That means OAP equals to OBP. OAP equals to OBP because these two are right angles. So these are equal, no? So because in reason you should indicate tangents perpendicular to radii. Radii. This is the thing you should indicate first. Tangent perpendicular. Okay, here perpendicular. To indicate perpendicular, no need to write perpendicular. Draw this and here mark a perpendicular relationship. Okay. This is the way we are using to indicate perpendicular to radii. Then second thing, this one OP is a common side OP. The reason we are considering about OP is a common side because this the side belongs to this triangle and this triangle. This is a common side, belongs to both of these triangles. Okay, common side. Now we know the congruence. Okay, fourth type of congruence, what it says, hypotenuse. Okay, hypotenuse and another side, hypotenuse and another side, if those are equals, we can conclude those triangles are congruent with each other. And next thing we know, that obvious one is OA and OB are equal. Okay, the third one here, this is our first one. Second one, I'll write the third one here. Okay, third is OA equals to OB. OA and OB are equals. That means those are radii of same triangle, of the same triangle, same circle, sorry, same circle. This derivation is all about to show these two triangles congruent with each other. Okay, these two triangles congruent with each other. That's the thing we are going to find here. Okay. What I did first, I indicated the data, and to be proved, I indicated those stuff. Then after, in triangle POA and triangle BOP, OAP equals to OBP. These are perpendicular. So tangent perpendicular to radii. Then OP is a common side, and we need at least three conditions to satisfy to prove a triangle is congruent with another triangle. Okay. Third one, OA and OB, these are equal because these are radii of a same triangle. Now, three conditions were satisfied. So, triangle POA congruent. For that, we are using triple line for equation, congruent with triangle BOP. Under the condition RHS. Okay, RHS. You know what is RHS? Right angle, hypotenuse and another side. Right angle, hypotenuse and another side. Then after, we have to write in congruent triangles, in congruent triangles, remaining corresponding elements are also equal. Corresponding elements are also equal. This statement, you should remember this statement. In congruent triangle, remaining corresponding elements are also equal. Okay. What we found, okay, hereafter we can indicate our to be proved values. That means we know this one and this one are equal, obvious one. This is one, this one also obvious one. That means common side. This one we studied this theorem earlier. These are equal. So what are our to be proved? AP equals to BP. Hence these two triangles are congruent with each other. We can directly write AP equals to BP. The reason we indicated earlier. Okay, in congruent triangles, remaining corresponding elements are also equal. So AB equals to this one equals to this one, and the angle this one and its corresponding angle this one. APO equals to BPO, and final one, this angle. Okay, the central angle, that means AOP, that one equals to BOP. That's all for our proof for